Find the general solution to the ODE, 3y prime plus xy equals x. All right, so first thing first, we need to get it into the right format, so we need just y prime by itself, so we'll divide the entire equation by 3. So we end up with y prime plus x over 3 times y equals x over 3. All right, next step, find the integrating factor. So first identify f of x, which is this x over 3. Integrating factor mu of x equals e indefinite integral f of x dx. So that's e indefinite integral of x over 3 dx. So that ends up being e to the, let's see, what is that? So x squared, and that's going to have a 2 and the 1/3 from before. And then the plus c we can drop. So that ends up equaling e to the x squared over 6. All right, so apparently that's our integrating factor. So let's go ahead and take that and multiply our ordinary difference equation. So we'll have e to the x squared over 6 times y prime plus x over 3 e to the x squared over 6 times y equals x over 3 e to the x squared over 6. All right, and fix that x right there. All right, so just double checking. You might have some faith by now, but I'm going to double check. So I have e to the x squared over 6y prime. Well, that's going to be non-derivative of the first, so e x squared over 6 times y prime plus e to the x squared over 6 prime times y. Well, okay, so what's that going to be? So x squared over 6 y prime plus, sorry, whenever we take the derivative of an exponential, the exponential sticks around, but we also take the derivative of its exponent next to it. So we're going to end up with x squared over 6 prime times the original exponential e to the x squared over 6 times y. Then just one more line here, we have e to the x squared over 6 y prime plus, so the derivative of x squared is going to be 2x, so that 2x, well, the x will stick around, but 2 can cancel with the 6, so that'll be x cubed, sorry, x over 3. And then e to the x squared over 6 times y, which is good because that's exactly what we have over here. E to the x squared over 6 times y prime plus x over 3 times e to the x squared over 6 times y. Right? Same thing. So we can either, you don't have to do this every time, I don't recommend it actually, but here we can rewrite this left-hand side as the integrating factor, e to the x squared over 6y whole thing prime is equal to x over 3 e to the x squared over 6. Right, next step as always, we're going to integrate to get rid of the derivative. So we're going to have indefinite integral of e to the x squared over 6y whole thing prime equals indefinite integral x over 3 e to the x squared over 6 dx. And sorry, I forgot the dx over here. All right, so on this side, the left-hand side, we're going to have the derivative and the integral cancel. So we'll have e to the x squared over 6 y equals, so this one you would normally have to do either a u substitution or just kind of figure it out yourself. We actually have the benefit of, I think, knowing, no, we're going to have to do a u substitution. All right, so let's go and do that. So if we do a u substitution, so we have integral of x over 3, sorry, x over 3 times e to the x squared over 6 dx. If we do u is equal to x squared over 6, then du is equal to, we take the derivative, so it's going to become x over 3, right? So x squared becomes 2x, a 2 can cancel with the 6 partially, become a 3, so it's just x over 3 dx. All right, and so we actually have that in here, so it's integral. We can lump together the x over 3 and the dx, so that's just du. And then we said u was x squared over 6, so it's really just e to the u. So the integral then is e to the u plus c, which is, if we replace the u again, it's e to the x squared over 6 plus c. So on this side, and you will have to probably review that, it's going to show up a lot in this course, it's differential equations. So we have x over 3 times e to the x squared over 6 integral ends up just being e to the x squared over 6 plus c. All right, and so final part, we have to solve for y. So we have e to the x squared over 6, y is equal to e to the x squared over 6 plus the constant integration. We're going to multiply both sides of the equation by e to the negative x squared over 6 to cancel out the one here. So that we'll end up with just y of x equals e to the negative x squared over 6 times e to the positive x squared over 6 cancels to 1. And we'll end up with plus c times e to the negative x squared over 6. That was a little nasty, but we got to the end and everything worked out.